here till 12:15.
So we have study hall?
No, you have Spanish. You have Spanish and study hall. It's going to be like, I'm going to give you your Spanish assignment. You're going to do it, and whatever you don't get done is, then after that, study hall. And I'm recording right now, so Senora Smith can hear any of your comments.
Great. Technically, they were offensive.
No,
you were moaning and groaning.
Well, she's good at Spanish.
There you go. See, Aiden's so smart.
That means Miss Rogers, you get to teach us.
Do you know Spanish, Mrs. Rogers?
No, I do not know Spanish.
Do you know?
No, I'm going to give you your assignment, and you're going to be good with it.
You get to teach us.
All right.
I can't wait for like Emily to come through the door.
Shh. I know. She will. She'll come blowing through the door. Hey, Emily. Okay.
We're gonna act like we just
Miss Rogers, pretend that it's actually Iowa testing week and don't let her in.
No, I'm not. Emily, you are allowed to come into my classroom. All right. Congruent polygons. Congruent. What does congruent mean? Gabby? They're exactly alike. They're equal. Okay, congruent means like equal. And we're learning about congruence and similarity today. Congruent polygons have the same size and same shape. Same size, same shape. For example, triangle A, B, and C. And so the attempt is that these are going to look identical. Let's see if I can do it. Yeah, that's pretty close. I'm good. All right. D, E, and F.
I'm not good. Mine are not.
Wait.
It's okay.
I have a question.
Oh my.
That thing under same, is the top one like that and then the
I've already
chain-
explained that.
You did?
Yes.
What'd you say?
I told everyone what that is.
Same shape, same size thing?
Yeah.
No, but like.
I know. I
can't
explained
see
what
it.
that is.
The first, the
I
top
explained
one?
that.
You did?
Yes. You weren't listening.
I was writing down. I wasn't
Oh my
listening.
gosh, I'm just joking. I never say anything. This is the symbol.
No, I'm just. Okay.
No,
guys,
shh, shh,
Are they
This-
all squigglies?
shh. Are you gonna listen? Now for real? Okay. This is the symbol for congruent.
I can't see it.
Shh.
Goodness.
This is the symbol for congruent.
Can you write it?
Now
down?
shh. Shh. Let me finish. This is the symbol for congruent. This is an equal sign with a wavy line on top. This is an equal sign with a wavy line on top.
Is it a tilde?
This is an equal sign with a wavy line on top.
Is it a tilde?
What?
Is it a tilde?
This is
Thing
not-
over the Spanish end.
Whatever that is. See, I can't teach Spanish. Sit down. Sit down. Sit down. Sit.
tilde.
Sit.
It is a tilde.
Sit.
It is a tilde.
Woo! Good job.
Okay.
I can't wait to see this video.
It's an equal sign with a wavy line on top.
Yes, it's a tilde.
Taylor, I've got duct tape in the cabinet. And it's camo just for you. All right, so this is the symbol you will use for congruence. Equal sign with a wavy line on top. I swear, Taylor,
That was in our Bible book.
Yeah.
I'm sorry. I
Say
promise, Taylor. Okay.
No.
What this is, so what we're going to say is these triangles, I'm going to show you what it means. These triangles right here are congruent. How do I know that? Besides the fact that I just told you, we know that because of the symbols I'm about to place on them. That little line right there is just an indicator for angle A. If I put the same indicator over here with angle D, that's saying that angle A is congruent or the same as angle D. Now look at angle B. I'm going to put 2 lines for angle B. Taylor, if you need to move up, you can. You can sit in Emily's desk. So that means, what this means is angle B is not the same measurement as angle A. See how there's 2 different lines? But I'm going to put the same 2 lines right here with E. So angle B is congruent with angle E. Do y'all see that? Does that make sense? So I'm going to put 3 lines for angle C.
Looks like the Wi-Fi.
That Taylor, duct tape. This is saying that all 3 angles are different measurements, that they are not the same. But I'm going to put the same 3 lines for angle F. So that means angle C is congruent or the same as angle F. So we see just by angles that these 2 triangles are similar. But we can't say they're completely congruent because of their sides. Side AB is congruent with side DE. See the little mark? And then I can say side BC is the same or congruent to side EF. So these 2 sides have 1 little notch. That means they're the same. But they're different than these 2 lines because they have 2 notches. But we're also saying that this side and this side are the same. Make sense? And then, of course, this side, I'm going to put 3 notches. 1, 2, 3. Those 2 sides are congruent.
Creators of Minecraft.
Taylor? So how you would write this is just like this. Triangle ABC is congruent to triangle DEF. Now, please understand how you write the letters really does, like the order, there you go, that's the word I'm looking for. It's been a crazy morning. The order of which I write the letters makes a big deal, like it's important. So if I call this triangle ABC, then I have to follow suit with this one. If I started with angle A and it matches angle D, then I have to start with D. If my second letter is B, then I have to write the congruent other angle next. Do you see what I'm saying?
Yes.
The way you put these letters down, I can't say triangle ABC is congruent to triangle FDE. Then that's wrong. I'm starting with this letter in this one, but then I'm starting with this letter in that one. No, that wouldn't work. Believe it or not, as silly as that sounds, because we're talking about congruency and similarity, you have to make sure the order of which you write your letters are the same. Does that make sense? Okay, question.
What if you didn't start with A and you started with C?
Okay, good question. She said, what if, I'm going to write this in red. She said, now give me an example.
CBA.
CBA. Okay, she said, what if I do CBA? Well, then we would have to write this one. That's a good one. So if I started with C first, that's this one up here, which do you think I should start on this one? That's right, F. The second one she chose is B, so then I choose E. And then her last one was A, so then the last one, this one would be D. That's a very good question. So do y'all see that? Does that help?
Yes.
Okay, good question. That actually, I should do that more often and show different ways. Yes.
If the triangle, like let's say it was a right triangle, if it was mirrored, would it still be congruent?
Oh yeah. Yeah, it can. Okay, so that's another good question. Here. Oh no. I have one piece of gum left. What am I gonna do today?
I will bring you more gum.
Oh, I'm gonna need it by lunchtime. We're not gonna have a break today. I'm gonna have y'all like all day. Okay. So for example, so Taylor said, what if we had a right triangle? And let's call this A, B, C. And it's, okay, these are supposed to be the same. And we call this D, E, F. This is another good question, y'all. He said, what if they're mirrored? Like you have this triangle and this one, they're supposed to be congruent, but they're flipped. Well, if this angle matches this one, and then A matched D, they're still congruent even if they're not facing the same direction. Do y'all see that? And these little notches actually help determine that. See, it's just mirrored, but it's the same. So I would say triangle ABC is congruent to, so Taylor, what letter would come first?
What was that? I can't see. D.
D. What letter comes second?
F.
If B was second and it's where the right angle is,
Oh, whoops, I was looking.
what would come next? E. And then if C is here, then F would be here.
I can't see.
Well, then move up. I told you, move up. Okay, does everyone see that? That's another good question. So as long as this could even be like facing this direction. It could even be like this. It could be upside down. I mean, it could be there. No, I'm not going to draw anymore. But it could be any direction as long as we indicate that the angles are the same and the sides are the same. It's fine if it's mirrored or upside down or something like that. Okay? Yes, sir.
But if it was a square, would you write one line on one side and then two and then three and then four on each side? Would there be 4 lines on one side?
Well, if it's a square, all the sides would be the same.
Oh.
Right? Okay, so let's move on.
Wait, I have a
So,
question.
okay.
Why isn't there one of these little line thingies on this side right here?
Oh, I just didn't put it, but
Oh.
we can have that.
I have a question.
Yes?
Would you put multiple of the thing indicating it's 90 degrees around it?
This?
Yeah.
Why would I put multiple ones?
Because
This is the 90-degree angle. This is not 90 degree. That's not 90
Are
degree.
you talking about a square?
yo, what if it was a square?
Now, don't worry about that. Let's move on. I have barely gotten into my notes.
Yeah.
Okay. So we know that angle A is the same as angle D. Angle C is the same as angle F. B is the same as E. Do we understand that? I don't need to write that down. Y'all get it, right?
Yes.
Okay. I'm going to put this in words. Even though I said it up here, I'm going to put it on paper. And so are you. When writing triangle ABC is congruent to triangle DEF, you must list the vertices, which are your letters, you know, the A, B, C, D, but those are your vertices, those points, right? Okay, you must list the vertices, which are the letters, of each triangles corresponding angles in the same order. And I've already talked about that, but I wanted to put it in writing. And if I have grammar mistakes up there, don't let me know. I don't care.
Hey, there's those. That's actually pretty good. I just remember that really sits as an artist is it.
I know. So if you want to sit there, you can.
I like just leaning back and getting my books like that.
All right. It's up to you. All right. Give you a second to catch up.
I like the spotlight.
Put your pencil down when you're done so I know. Similar polygons. Okay, we talked about congruent polygons. Now we're talking about similar. Similar has the same shape, but not really same size. The sign for that is one squiggly line, not the parentheses. That's just showing you.
So it's just a tilde.
Do what?
So it's just a tilde.
Taylor?
What's that weird thing?
Taylor.
In the corner. Or left.
Shh. Angles will be congruent. That's right. Angles will be congruent. There's my congruent sign.
I just realized something about similar and congruent.
There's a lot I'm realizing right now. So go ahead and share what you're realizing.
For the symbols, the similar sign is on top of the equal sign to show that it's exactly the same, but with similar, it's just a sign because it's saying that it's not equal to, but it's similar.
Sides will be proportional. Scale factor. Moving on. I'm going to give you an example. pretty much most of my drawings are going to be similar. Not in reality, but, I mean, yeah, in reality, but I'm trying not to be. So, here I have a big old triangle, and then I have a smaller one. Now pretend that they're, well, that's pretty close. They're supposed to be like almost identical, just a smaller version of each. So we'll call this A, B, and C, and D, E, and F. So angle A is the same as angle D. Now guys, please understand, and I need you to wrap your head around this. Even though these are two different sizes, the sides are going to be different length, right? That's obvious. But the measurement of the angles will always be the same. If you were to take a protractor and measure, probably not my drawings, but like ones in a book or professionally done, and measure both angles, you will find the exact same measurement. So it doesn't matter how big or small, the angles are going to be the same if they're done similar. Okay? And C and F will be the same, and B and E will be the same. So if these angles are the same, and this side is 6, and this side is 12 and 9, but this side is 4, this side's 8, and this side is 6. Are they congruent? No. They're similar. So make sure you draw that. I have, Taylor, move up, please. Move up. So let's say side AB, we're talking about scale. Let's do a scale. AB is what measurement, Joanne? Side AB.
6.
And side DE, which is its same or it's similar, is what?
4.
Okay. So if we reduce that, what do we get?
2/3.
Lowest terms? What number goes into 6 and 4?
2.
How many times can 2 go into 6?
3.
And to 4?
2.
So your scale is 3/2. Let's check to make sure all of the other sides work. And look what I'm comparing. I'm comparing side AB with its similar one, DE. AC with DF.
So will you always
Okay, here's autonomous.
Sorry.
will you
Siri,
always,
I don't know, what's her problem?
will
Okay.
you always start with the first angle?
No. No, you don't have to. You just choose random ones.
So I could choose ED.
Yes.
Oh,
So AC, we're going to go with this one now, AC, and we're going to compare it with its similar side of DF. See, we're using, but if you choose AC, you can't do EF. You see what I'm saying?
Mm.
You have to choose the same sides, right? Do y'all understand that? Izzy, do you see that? Okay, so Izzy, what's the measurement for AC
12,
and DF?
8,
All right, and if you simplify that, what do you get?
And then
And then
3.
3/2. All right, so far it's working out, right? Okay, so Michaela, what's my last two sides to compare?
EF
BC.
Okay, so since we've been doing the large triangle on top and the small on the bottom, what do I put on top?
BC.
BC over,
EF.
why can't I do FE?
Because they're not the same.
There you go. We have to put them in order. So what is BC, Michaela?
9,
And what is EF?
6,
And we can simplify that to,
3 over 2.
See that, guys?
Mhm.
Therefore, the scale factor for triangle ABC that is similar, see how that sign changed? To triangle DEF, and I have to write them in order, is 3 to 2. Or you can say 3 to 2. Any questions?
I like the voice of your Siri.
Oh, I put it in British. She has a British accent on my phone.
My mom's new car has Siri.
I don't understand why it keeps coming on at random times.
You end up.
Because you probably say something close to Siri.
It must, but I didn't know our phones could hear us talk when they're not even
Oh,
on.
You can.
They can.
The government.
It's the government.
The government,
I'm telling you,
yeah.
it's the government hearing me
change.
teach math. They're all sitting there in some office learning how to do similar, congruent
This
triangles.
Miss Rogers,
The more you know.
you can change what word you say for Siri to come on. So you might have done that. on
Oh,
accident.
with computers, you can be talking about, say, a weed eater, and then on Quizlet, the ads on the right will be up.
It happens on
and, like,
social
really-
media. If anyone in my house Googles, I'll let y'all catch up, Googles anything, like Allie
Minecraft.
the other day was Googling Build-A-Bear for some reason.
Uh,
And I'm on social media and I start getting all these ads for Build-A-Bear. I'm like, who in this house is Googling Build-A-Bear? Or it could be like, oh, I found out my husband was Googling lawnmowers. Like looking at lawnmowers. I started getting all these ads for lawnmowers. And we don't even share phones or anything.
thing is,
That's the government watching
That is so cool.
us, Google Build-A-Bear and lawnmowers.
I don't get specialized ads because I
I'm
always
just
go
kidding.
on Minecraft.
Yes.
All right. So here's another example. Let's get given triangle RST. Notice notice how I'm writing them. RST is similar because that's a similar sign. X, Y, Z. Okay. Notice the order of which they're writing. They're listed. I'm having trouble. R and X are first. Notice which ones come second and third. They say that R and S, that means side R and S is 9. Side R and T is 18. Side X, Y, we don't know. And side X and Z is 12. We have to figure out the unknown. What will it be? Now, I'm going to show you 2 ways of doing it. No, I'm going to show you steps to do it. Step 1, and this does help, guys. Draw a picture. We know that they're similar. So are they going to be the same size? No. We don't even know which one's bigger or smaller. I'm going to assume this one's bigger because if R and T, see the first and the last is 18 and the first and the last is 12, then this one's bigger. So I'm going to draw it. I don't know what shape it is, but I'm going to draw similar triangles. R, S, and T. Now I have to do it in order. X, Y, and Z. Shh, excuse me. one more time and I get the folder. R and S is 9, R and T is 18, X and Z is 12, and we're looking for this one. We don't know what it is. Make sure you draw it appropriately, and then you put in the measurements. Does everyone see where I got these measurements? They were given to us, okay? Yes, Whit?
Why don't we have a measure for ST?
I don't know, they just didn't give it to us. But to find this measurement, we don't even need this. And you're going to find that out. All you need are two similar sides measurements to find out everything else. You don't even need these two sides. You just need one pair of sides to be able to find out this, to be able to do a scale. So step 2, but that's a very good question. Does anyone else have a question before I move on? No? Okay. Set sides proportional, meaning we're going to do the fractions. So RS, right? RS, we're going to put the larger one on top. What do we put on the bottom, Cecilia?
Right.
No.
Right.
What side do we put on the bottom?
XY.
Yes, XY. Now we're setting up a proportional. Proportional is done like this. We're comparing sides. So we put the large on top, small on the bottom. Does everyone see that? So we're going to compare it to the two sides that we have measurements for. So RT, do I put that on the top or the bottom, Joanne?
RT, you put that on top.
Okay, why do I put it on top? Say it.
Because that's where RS,
And the RS is which triangle, big or small?
the big.
That's right. See, I know you've got the answer in your brain. You're just not sure how to say it. So the big is on top. So if I'm going to put the big on top here, I got to put the big one on top here. So I'm going to say big and big. If you put the small on top, then the small should go on the top over here. But I always do the big one. So then what goes down here, Izzy? Huh? XZ. Because I'm comparing RT with this little similar side of XZ. Now I'm going to fill in the numbers. What's the measurement for RS? I'll put over here. Izzy, what's the measurement for RS?
9.
The measurement for XY?
Oh.
Do we know what it is?
No, we don't know.
Okay, so what can we call it? You want to call it I for Izzy?
No.
I'm doing that.
I guess E.
E?
Yes.
I'll put a lowercase e.
The beam E.
Okay, so we're going to call this E for Izzy. Okay. What is the measurement of RT, Cecilia?
18.
And what's the measurement for XZ, Michael?
12.
Okay, so one of our, quote, fractions has to have the measurements to be able to find the missing one. So question, who here knows what to do now? Taylor?
Reduce.
No?
Wait, no,
Whit?
You cross multiply.
Ding, ding, ding! Two fractions and an equal sign? We cross multiply. 12 times 9 is what? 108.
Bless you.
E times 18 is 18E. So then I have 108 equals 18E. Izzy, how do I solve for E? Bingo. Divide both sides by 18. And I'm just going to give you the answer. E equals, or does anyone know?
Why do you divide by 18?
Because we're multiplying. Right? Intruder alert. Do you remember? Are you sure you understand?
Mm-hmm.
With
6.
bingo. Okay, so to find out the missing side, you have to set it up as a proportion. Make sure that you have the big on one side and small on the other, or on top and bottom. Make sure that you compare with two sides that have their measurement, and then you cross multiply. Make sure you set these suckers up correctly. RS goes with XY. They should be set up like this. And they should be compared to two sides that already have their measurement. Make sure that you don't accidentally put the small on top and the large on bottom and then reverse it over here. They have to be the same. Is this about this? Okay. Anyone have questions about what we did? All right, let's move on. Open up your books to page 517. There's no reason to.
Fair enough.
Number 2. I'm waiting for everyone to have their books open. There we go, to the right page. Okay, Aiden, why don't you read the directions?
In a given triangle congruency statement, congruent statement, split the following statements by congruence of corresponding parts.
Okay, so number 2. It says if triangle TAC is congruent to triangle EDV, then angle C is congruent to what angle? Gabby? Angle V. That's not so bad, is it? So angle C is congruent to angle V. Excuse me. Make sure you put those symbols in there. And what we're focused on is order. This is what they're trying to get across, is order matters. Any questions about number 2? All right, let's look at number 4. Triangle NML is congruent to triangle AXK. Then angle M is congruent to Cecilia.
Triangle X.
Triangle X? Triangle?
Triangle.
Angle M is congruent to,
Oh, angle.
there you go,
I just realized what
angle X. Good job, Cecilia. Because angle M is in the middle, so angle X would be its congruent angle.
Miss Rogers.
No? Thank you, Cecilia. Good job. Let's look at 6. Any questions about that? Triangle RPQ is congruent to triangle HCL. then side RP is congruent to which side? If they're looking for the congruent side to RP, Izzy? That's right, and she even put it in the correct order. Any questions? All right, 8. Let's see. Taylor, read the directions. No, in your book.
Given triangle similarity statements, complete the following statements of congruence of corresponding parts.
Okay, so this is very similar. So if triangle DXP is similar to triangle MFZ, then DX over MF is equal to DP over what? So think about it. With
MZ.
he is correct. MZ. Because DX is being compared to MF. And then DP, side DP, would be compared to MZ. Any questions? All right, let's move on to number 12. I see people still writing, so I'm going to let them catch up. Just a second, please. Okay,
I've had a revelation.
not right now, Taylor. All right, 12. Gabby, can you read the directions?
Find corresponding parts of the following.
All right, so look at the figures. You have a pair of triangles and then another pair of triangles. Do y'all see that? Okay, so number 12, it says angle C. It says find the corresponding parts. So what angle corresponds with angle C? Joanne?
Angle D.
That's right. So it's congruent to angle D. Any question? Let's look at 16. So now we're looking at the other set of triangles. Side TS. Now that's obviously not congruent. Is similar to what side? Michael?
WU.
Very good. And you said it correctly. Side WU. Any questions? All right, let's look at 20. It says use proportions to find the missing links. Round answers to the nearest tenth. So use proportions, that's the two fractions with an equal sign, to find the missing links. Okay, so for 20, we have, I can't even see this. Hold on. Looks like we have two missing links. No, we don't. Yeah, we do. We have a Y and an X, so we got to find those. Why didn't I draw pictures? Oh, I did here. Okay. So I'm going to draw them out. This is probably not, the best. I don't care. You get the idea. Okay, so that's what's in your book, and that is a crazy looking triangle. All right, so we gotta solve for x and y. All right, we gotta solve for x and y. So guys, watch very carefully how we do this. We're gonna first solve for x. We're gonna set it up as a proportional. So Izzy, we're going to start the big triangle. What side is x? And what side does it correspond with on the small one?
D.
What?
D. E.
There you go. Now, what two sides should I choose for over here? Gabby?
A. C.
Oh, yeah.
Well, if I do AC on top, look, DF has a Y. So we can't choose those sides because they both don't have measures yet. So the only sides that I can choose to do any comparing are those two sides. Those are the only ones with measurements. We can't choose these to compare. Do y'all see that? So what goes on top, Izzy?
B. C.
Very good. What goes on the bottom, Gabby?
E.
All right. So now we have our sides in the correct proportional. So, Cecilia, what is AB? What measurement is it?
X.
What measurement is DE? Cecilia.
4.
Joanne, what measurement is BC?
12.
And Aiden, what's EF?
6.
Now what do we do, Michaela?
You're going to cross multiply.
Very good. So 6 times x is 6x. And 4 times 12 is 48. So then we write 6x on that side. You can't switch sides, equals 48. Cecilia, what do I do now?
Divide.
Okay. Why am I dividing?
No.
How do I, look up here, how do I solve for x? How do I get x all by itself?
Alright, yeah, divide.
Okay, very good. See, you know this. So to be able to get x by itself, what operation is taking place right here?
Multiplication.
That's right, and we have to do the opposite, which is divisions, because we're isolating x by itself. We want to get it all by itself. So we divide both sides by x. So x equals 8. Any questions? Now we gotta find y. Solve for y. Alright, so what is my first, Michaela, what do I put as my first fraction? We're solving for y.
Still 20.
Yes?
We're going to do DF.
Okay, so you want to put the small one on top first? Okay, so she wants to put the small one on top first. That's absolutely okay. So what do I put on the bottom then?
AC.
Very good. So notice on this one, we had large on top, small on the bottom, and small on the bottom. She's decided she wants to put the small on top and large on the bottom. You can. But, Michaela, what do I need to put over here?
Oh, BC. No, EF first, and then BC.
Perfect. If y'all don't know what she's doing, you need to say something.
Could you also do DE? But could you also do that?
Well, now that we found X,
Oh yeah.
you can, but you need to stick with the sides that already have the measurements.
So you.
These two originally had measurements. I would stick with those. So this is done correctly. But you can put the small on top as long as the small stays on top. Do y'all see that? Okay, so what's the measurement of DF? Taylor.
The measurement of DF is we don't know.
So what do we put there?
Y.
Very good. What's the measurement of AC?
10.
What's the measurement of EF?
6.
What's the measurement of BC?
12.
What do I do now?
Cross multiply.
I have 12y over here. 10 times 6 is 60 over here. So I have 12y equals 60. Cecilia, how do I solve for y? Very good. And I get y equals 5. Any questions? Any questions? All right, I think y'all got it. I hope y'all took good notes. Y'all are going to do let's see.
Is it just page 517?
You're going to do, write this on the back. Page 517 to 518. Numbers 3 through 17 odd. Then 21 to 27 odd. This is due Thursday. All right, get started. Hold on.